because I didn't have enough room, just that whole load balancer stuff there, etc., is the same, but it comes in at the top on the API layer. So in a really, really big web app, one that's serving many, gigabits a second or petabytes a second or something, that's terabits a second or whatever. This is more like what your system's going to look like. I guarantee you're going to have a separate API layer. You're going to have separate core services that's going to communicate possibly to some kind of database cluster or database clusters, depending on what it is. Maybe you have a separate analytics database, maybe you have a separate user database, etc. The point is that you have multiple databases of some kind here. And your API layer is going to share some kind of cache, and cache key, whatever, etc. it might be. And then this here, I should have labeled this, but this is actually the SQS icon, the Amazon SQS icon. It's the simple queue service. You're likely going to have some kind of asynchronous queue, and you're going to have separate worker instances. This is a mistake. I meant to, I don't know what happened, but this was supposed to be duplicated, meaning you have multiple workers here, more than 0. More than 0, less than infinite. And these also communicate somewhere to the database. The reality is maybe they also have their own caching layer, who knows, but if you're building it correctly, they're using the queue as a cache, etc. And again, this queue might be simple Amazon simple queue service, it might be Redis, it might be, I don't know, there's 1,000 out there, right? Your man, whatever you want. So all of the big websites that I've built have had architectures that look something like this, or more like this. And the reality is that you can't really get much more in terms of scaling than past this. You can start adding more and more layers and tiers here, but at the end of the day, you get diminishing returns on what that does for you. And then if you need to scale this out, what you tend to do is then you put this whole thing in a giant box, and then you just copy this box, right, to the side. And that's basically what you do. So how do you do that in Go? So it's not really unique to Go. It's just, this is just what you do to build a big website in general, okay? You split up your tiers between views and business logic. That's very important. And that might be something that makes sense in the evolution of your application. So for instance, maybe you want to get rid of your current database tier, data layer, or whatever you want to call it. And it's a legacy PHP application, a Ruby on Rails application, and you just want to have Ruby on Rails do what Ruby on Rails is really good at, which is like the front-end API, or sorry, the front-end web pages, and then just basically have Go serve the API. So Go is like a great instance for that, where basically you take an existing app, you swap out the data layer, and you put Go in its place. And you will be surprised at how fast and easy that is to do with Go. One thing that is unique to Go here is that group cache. So group cache is essentially a single write cache, meaning that you cannot write over values. And when you start building really big sites, what you tend to do is you tend to put things into buckets according to time. It's hard to explain why you do that, but just trust me, that's what you're going to do. Group cache is a Go implementation written by, I think it's Brad Fitzpatrick. I think he's the guy who wrote it. So Brad Fitzpatrick is the guy who originally wrote Memcache, and he now works at Google writing Go. And he did a LiveJournal. Or sorry, is that LiveJournal? Yeah, LiveJournal. That's what he's famous for. I think he made some money out of that. Anyways, he wrote Group Cache, and that's what they use to Go for one of their caching layers. When you build something like Go, you're going to have 10, 15, 16 layers of cache. But if you need to get a caching layer in place, I would highly recommend using Group Cache instead of Memcache. It's native to Go, it's really fast, it works great, and it works in a clustering environment really well. And I feel that you get a better understanding of what it is. So try to stay away from ORM. There are ORMs in Go. There's Norm, there's North, there's a couple others. There's nothing wrong with them, but it's just the same problem that you have using an ORM in any other language. Whether that's PHP or Ruby or whatever, it doesn't matter. So this is also something that is specific to Go. Terminate TLS is a load balancer. Go is still kind of slow when it comes to TLS. They're really trying to improve that in 1.7. But it probably isn't going to get fixed, ever, maybe. So if you're at the point where you need to start looking at the performance of your SSL, or your TLS sockets, move it to your load balancer if you can. The load balancer implementations tend to be written in a combination of C or assembly, so they're quite fast when it comes to doing that, and they might even have hardware-based TLS boards, so they can do TLS quite fast. So that's kind of it, and then so that is kind of unique to Go, but that's just kind of something you get performance gain anyways. So I rarely see large applications where TLS isn't done at a load balancer or at some kind of layer in between the load balancer and the actual applications. And then kind of the other thing here is to separate queue workers from the application server. So meaning that if you've got async processes, tasks, sending emails, whatever, separate that out, right? And basically anything that you can offload to a synchronous worker, do it, right? So things like sending email. Even if you can get away with even just a 1 second delay, then send it to an asynchronous worker. You'd be very surprised at how much performance gain you can get from doing that. And again, most of these are not unique to Go. These are just general scaling principles. So if you're not familiar with this, now you are. So hopefully you can go build good one. So, all right, so that's it. I didn't want to say, so I've been speaking now for an hour and a half, which is right around 5. That's it. I mean, so let me show you what I mean by that. Okay. So the stuff that's red, those are executables that were built by Go, right? Just to give you an example. Shit. I don't know. I don't know. Maybe I don't have it set up correctly, but if you were deploying a Go app, literally all you have to do is you rsync the executable, and that's it. Assuming that there wasn't an error in the data transfer, you have everything there. But that means, though, that if you have static assets like HTML files or something, you need to get those over there as well. What I do on deployments for apps these days, if it has static assets, I actually compile them into the Go binary. And that's it. There are no other dependencies. There is no NPM. There is no package manager. It compiles, it runs, it works. For what? Jenkins. Yeah, you compile it on the system there. Okay, so if you want to do versioning, Go 1.5 introduced the vendor directory, right? So what you would do is okay, so and here's my consulting company. All right, so All right, so I don't know why the error is coming up, but whatever. I don't really use those that much. Sorry, I'm just doing a really simple example real quick. Okay, so basic convert is a simple library that I wrote to essentially convert between arbitrary bases. Don't worry about it. This should build around it. Okay, so all right, so there. Okay, so alright, so that's a simple package, right? So Go 1.5, what you would do is that, at least what I would do is I would actually commit and compile all of those dependencies into the same repository if you can't depend on its location. You need a very specific version. There are tools that do this, but I find them unnecessary. So what you would do is so right now I have the system-wide base con package, which is the standard location for for Go packages. Okay. So what I will do instead is I will copy that package into the local vendor directory, make changes as necessary, and then I will commit those to the repository, and that will be the version that's being used instead of the system-wide one. Okay. All right, so okay, so basically because it's in that okay, so all right, so now that okay, this is basically what it ends up looking like. Okay, I have that package on the local repository. Alright, so it's using that base quantity, and notice that it's compiled, etc. So to show that it's using that in that file, then I'll just basically modify it in base quantity, go code 62. Alright, so that's what you do on package management with Go. There's no dependencies, etc. It compiles, you have the local copy, etc. Now obviously this becomes a pain in the ass when you have hundreds of package dependencies. There are tools to simplify that, but I mean, that's really outside the scope of getting that. But if you want to see what I do, so I would write some kind of a shell script that updates things. So I don't have dev listed, so the I never had it on or something, so I don't know, whatever. There's a Go tool called devlist that basically gives you the dependencies of all the packages, and you can use that in the shell script to do like get minus, go get minus u, and then you can output it to that specific folder, and then add it to your Git repository or your Subversion repository or whatever it might be. So, but no use of money. All right. Any other questions?